We're going to move over to Tim now, and Tim has, Tim had reached out to me a couple of years ago and said, "Hey, we're doing a project and we need to comply with CMMC. How do I do this? How do I do that?" And I had to keep telling them, like, nobody does that. We have nobody. There's no way to do that. And so Tim has put a lot of time into making ways to do that, and then he published those as open source. He's going to share those with us now. So, Tim, you can go ahead and share your screen.
Yeah. Awesome. Sweet. Oh, awesome. So kind of before kind of getting started, I just wanted to highlight, so the tools Sam just shared for SBOM generation, they're fantastic. So we've already taken them, we've implemented them in our company, and we're using those to generate SBOMs. We very rarely use VI packages, but we use them for all our projects, right? Creating those SBOMs right now. So we've already kind of taken it and started leveraging it, and it's been fantastic. So just a kudos to Sam for helping develop that. So yeah, I just have a few tools, surrounding general security in LabVIEW, just because LabVIEW does not have very good tooling for security. A lot of things that have to be developed, through the community, that, a lot of other programming language, you kind of can just like find a tool, download a tool, use a tool, right? Even like static code analysis or static security testing, it's built into most of the IDEs, it's built into like GitLab, GitHub, stuff like that. And so there's just a lot of tools that you can just use that you don't have in LabVIEW. So trying to have good tools around those things. Also kind of a disclaimer on me, also not a cybersecurity professional. So I am a mechanical engineer, right? Kind of been learning as I've gone, as our company's been venturing into CMMC. So definitely not a cybersecurity professional. So take everything I say with like a grain of salt. But yeah, I do have, so I am like CompTIA Security Plus certified, and I am ISC2 certified in cybersecurity, which are relatively simple kind of IT cybersecurity certifications. But it did help me learn kind of some of the fundamentals of kind of some of this security stuff. So I worked for RAM Aviation Space and Defense. And yeah, just wanted to kind of highlight what we are so I can provide some background on kind of our adventure in CMMC. So we are located in southern Utah, St. George, Utah. We are a manufacturer of a bunch of different electromechanical aerospace components. So we do solenoids, solenoid valves, LVDTs, stuff like that. So been in business, just started our 50th year in business. Kind of just a quick overview, right? Some of the commercial platforms that we're on, commercial aircraft and engines that we're on. Some of the military platforms we're on. So we're on, some various military aircraft. We're on, some drones, tanks, guns, ships, all sorts of stuff. And this is where a lot of our CMMC requirements are being fed down, as a function of these products right here. We're also on some space applications as well. So, we've been working with companies like SpaceX, Blue Origin, Sierra Space, providing a lot of thrusters for our space applications and stuff. But yeah, kind of our company, we've been working towards CMMC compliance for a while. A lot of that has been driven by our customers as well. We've had customers, when we've gone to bid on different contracts and stuff, say, hey, you don't need to be CMMC certified or compliant or whatever, but you do need to at least be compliant to these controls in NIST 800-171. And so, that's kind of sparked, like a knee-jerk reaction to just trying to like, hey, really quick, get compliant to these things. And so, yeah, as a whole, as a company, we've just been pretty aggressively attacking, CMMC compliance. As a result of this has kind of changed a lot of our workflows. So the way production can operate, the way test and measurement operates, and the way software development goes, all of that's kind of changed and is actively still changing. We're not, compliant yet. There's still things that are in the works. But yeah, this has been a big balancing act between IT and OT, right? And kind of in OT, I'm kind of grouping in test and measurement, even if it's not necessarily OT technology, but yeah, just trying to find a good balance between, hey, what we're doing, has to work for both, right? And not be overly burdensome, but still meet requirements. So there's been a big act of just figuring out what's the right balance of everything. So as such, kind of started developing tools to help get us to that state of compliance, either just for simplifying development for different people or just tools that were non-existent. All these tools I'm going to share, they're all free and open source. There's a link to the repository. You're welcome to just do whatever you want with those. You're welcome to just use them as they are. You can take them, you can modify them and do whatever you want. And if anyone wants to help, collaborate on these and help, develop them further for the entire community, totally open to that too. So if you want, feel free to do like a pull request. At some point, I'll probably start moving some of this stuff to VIPM, but it's not really in that phase at the moment.
I want to say thanks for that, because you're about to see a lot of really great tools, and I want to reiterate, like, it's free. You put them all up there. You must have spent a lot of time creating these things, but they're all up there, and they solve a lot of the problems that we have with LabVIEW code. So this is really awesome.
Thanks, Steve. But yeah, kind of before we get into this, I just wanted to highlight the biggest changes that we've made as a company that have affected kind of test and measurement. So this isn't all of the changes we've made as a company, but what has most impacted the way our test teams have operated, which is what I've been most involved with surrounding CMMC. And if anyone has questions, wants to stop me at any time throughout this, feel free to. But yeah, these are the biggest things that have impacted the way we've operated. So first, not having shared logins on computers. So a good example, right? Before, you maybe had like a test stand that the username for the computer was test stand and the password was test stand. And, it was easy if one operator was running a test and they left, another person could just walk up and sign in and, pick right back up where that, last operator was in the process. Well, that doesn't really work anymore, because now, if the software is running on one user's account and then another user signs in, now you've got to do some figure out some way to kind of do some handshaking there, and be able to have the data, maybe the current test results that might not be complete, be able to be transferred over to another user, and trying to figure out how to manage that. Computers going to sleep after 15 minutes of inactivity. So in some use cases, it's not a big deal. But for example, if you have a test that's running on some sort of computer or something that runs for 2 months, some user signs in into their unique login, and then they walk away for 15 minutes. Well, now it's locked, and they're the only ones who know the password to where the software is running. And so no one else can even check on the system or do, if they need to interact with it, so just, yeah, that's been a bit of a pain point as well. Operating system updates, so like Windows updates on computers. So our IT team has allowed us to push updates for up to 4 days out. So if there's an update that needs to happen, we can reschedule that. We can only push it out a max of 4 days though. So, if you have a test that's running for weeks or months, that, doesn't solve the issue. We've also gone ahead and we've completely separated our OT network from our IT network. So our OT devices are going to be like our compact Rios, devices like that. We've got IoT sensors, different gateways and stuff like that. That's not kind of our industrial IT equipment, like our, servers that IT sets up, and our, our workstations and computers and laptops, anything that's really not in that realm, we've kind of designated OT. But we've completely separated them, so devices on the OT network can't actually interface with devices on the IT network directly. So this has created a bunch of challenges as well, because, for example, if you have like a compact Rio-based test system, you might have some sort of remote client software that you're using to send network commands to the compact Rio to tell it what to do or to pull data back off of it, or whatever that might be, or a web interface or something. But now, if you're trying to run that client or that web interface on our enterprise network on the IT side, it no longer can reach the compact Rios. So we've had to come up with ways to, create what we've called like a demilitarized zone, where we have like basically servers that have an interface on both sides, and it's a single server that's what has an interface on both ends. So everything has to go through that. So it kind of turns, if I have some sort of client on my IT network that needs to send data to a compact Rio, it has to send the message to software that's running on the server has to receive it and then be able to transfer it back to the compact Rio. And then if the compact Rio needs to send it back to, some sort of data or confirmation or whatever it is back up to our IT network, has to go back through that server. So, you've kind of turned that into, multiple moving pieces and whatnot. So applying security for data at rest and transit. So making sure that we're properly encrypting data when we're sending it over the network or when we're storing it, locally on like a file or something like that, or, and we are like, encrypting drives and whatnot. Application whitelisting is another big one. So, just denying all software from even being able to execute unless it's on like an approved software list. So, and this is version specific as well, right? So if I have some sort of third-party software and, it's approved, but then they release a new version and I try to go install and run that, it's going to be blocked, right? So before going through the security team and going through the proper checks to get tested, which does impact development quite a bit because, especially as a developer, I feel like I'm always downloading stuff, trying stuff, maybe playing with different ways to do something. So that's definitely changed kind of some of the development workflows. Our IT team also has pushed very hard for us to no longer log data to files and instead move more so to databases where we can kind of restrict access to kind of even a further degree of who can actually access this, right? A file, especially if you have some file dialog pop up and a user can select to, either put it in their downloads, put it on their, desktop, log it to like a file share or something like that. And then, whoever has access to those directories can access this. So big push to move all that logging to databases. And then also replacing actual physical hardware, right? So if we had, like Chinese made components, trying to replace those with like US made ones. So a good example is we had quite a bit of Modbus gateways that were, like the serial to, so it does like Modbus RTU to Modbus TCP gateways. And they were just, kind of some cheapo Chinese ones that someone had found online. So going through and just, replacing all of those with US made components and making sure, the hardware we buy kind of going forward is secure. So kind of surrounding that, we've got a few different tools that, kind of have been developed or are being developed to help kind of simplify this. There's a lot here, and I don't think I'm going to have the time to actually get through everything, but I've kind of tried to put what I consider probably the most universally beneficial stuff towards the first, and I'll get through what I can get through. And yeah, this will all be available after the fact too. And if anyone can reach out if they have questions and whatnot about any of these other tools after the fact. So yeah, kind of starting out, I do have a TLS API. So this isn't anything super groundbreaking. So it's built on top of the native LabVIEW TCP functions, and it's built on the native LabVIEW TLS functions, and also the NISTM library that's available on VIPM. So the reason for the development of this tool was, as we started looking into encrypting data that's being transmitted over the network, we realized, okay, well, the TLS functions were released in 2020. So that was a big, fantastic improvement for LabVIEW that was available. Just, getting that actually working and implemented, you have to go through some examples and see, okay, well, what's the proper order of operations, and, kind of negotiating that TLS communication. Once it's established, right, it's just read and write, and it's pretty simple. So, got that figured out working, but then trying to, hand off components of that to other developers who could be brand new, they've got to figure out and learn how to do that themselves. So trying to make that just simpler to implement TLS, I've gone ahead and created 3 separate classes. Where each class basically just has like a start, stop, read, and write. And kind of all the, inner workings are handled internal to the class, right? So, your start, initializes, it connects to the certain port, it negotiates TLS, it starts the TLS connection, and from there, you don't have to necessarily worry about it. So there's a client class, a server class, and then here in the center is a multi client server class. So this would be one that would be listening to any amount of clients at any given time and being able to respond accordingly. It has the ability to send data to a specific client or to broadcast to all clients. Just trying to simplify, hey, if I want to use TLS, I can just drop this class down, and then it's really just like a start, stop, read, write, and I don't necessarily have to worry about how do I properly configure TLS and whatnot. Goal is just to make using TLS in LabVIEW just a little simpler. Have just a simple
the encrypted communication between applications. That's one of the requirements of 801.21 encrypted communication.
Yeah. And I just have a quick demo here showing just a simple, sending data from client to server with Wireshark listening. So I have it set to my loopback adapter. So just because I'm sending from localhost to localhost, and I do have it filtered for the specific port I'm sending data on, just to highlight that this data is being sent using TLS. Encrypted data. Just trying to kind of lower the barrier for entry into using some of those tools and make them easier. And then if I don't program anything that uses TLS for a while, I don't have to refigure out how to use TLS or go look at old code and whatnot. I have this class. I can just I know everything's kind of managed internally. Kind of along the same lines, I also have a DTLS API. For those who don't know what DTLS is, this is basically encrypted UDP. You get a lot of the benefits of UDP, but you get a lot of the security that TLS provides. A lot of VPNs use DTLS because it's faster than using like a TCP-based TLS, but still provides really good security. You do still have some of the potential risks of using UDP in that there's actually no, packets are never retransmitted. You're not actually guaranteeing that they were received or that they're received in the proper order. So there are still some caveats there, but in a lot of cases that doesn't really matter. So I've created a client and a server DTLS class. This is all built using some .NET libraries for the DTLS implementation. Just kind of drop down some of the functions so you can see. This is one tool that's still kind of in testing phase, so I would call this a pre-release. It is pushed to that Git repository, but I would not incorporate this into your production systems yet. Still in active development, working on it, but a good way if you want to use DTLS to be able to use that simply in LabVIEW, because right now there is no DTLS implementation. Another thing, so kind of talking about computers, we've got unique sign-ins. We've got computers are locking after 15 minutes. We're trying to send data across separate networks now from like our OT network to our IT network and stuff like that. And so just as a result of that, there was just a huge need to be able to run LabVIEW as a service, Windows service. For a couple of reasons, and I'll explain those. Trying to figure out how to do that, right? You can use kind of PowerShell to kind of do it for you. There is one toolkit I found that is a paid toolkit for LabVIEW that allows you to, start LabVIEW EXEs as a service. I kind of went around and just tried to make my own. So this is a full API for starting, stopping, restarting, installing services, removing services, etc. And then I also built a GUI kind of for service management. So you can go and view a list of services, and you can kind of just click a button to start or stop them as well. So the API is usable however you want. Also a GUI just so you can, it'll return a list of all your services. You can search by name and it returns the details. And this is all built kind of leveraging the NSSM technologies, but kind of LabVIEW wrapper around that. So we use this a lot for all sorts of stuff. It's helpful. So like if we have for example, we're setting up a server that's spanning our IT and our OT networks, being the go-between. We want it to be always running, so we need to be able to run this LabVIEW code as a server. Another use case would be we've got some sort of test system running on some computer that's interacting with a whole bunch of hardware. One of the issues we run into with that is, oh, someone who is signed into this computer left the software open, and it's still signed into their account. Someone else goes to sign into it, and the hardware is all reserved by the first user. So, the second user is getting errors, or, and you can try to create some way in your code to kind of do the handshaking there to, release the hardware, like when the computer locks or something like that. A better way we found was to just deploy all the hardware handling and whatnot and your test execution to a service. So that way, and then what the users are actually using is just like a thin client that interacts with that service. So as soon as your computer boots up, the service launches and it starts communicating with the hardware, collecting data, etc. And then regardless of what user is signed in, they can interact with that service. They can, yeah. And then, if they close out of their application, it's not going to stop a test. Or if someone else needs to get on, you don't have to worry about, oh, well, the hardware is reserved by that user. We got to restart the computer so it closes it out for them. And, just a bunch of headaches we had kind of doing stuff like that. So services was a good way to kind of get around that. And I kind of have just one example here. If it'll pop up. So this would be just a simple example where we have a bunch of CDAC hardware all throughout the facility. And we just have a simple service set up that just is pulling data from that CDAC hardware and logging it to AWS. And then we've got, a Grafana web interface so we can, monitor that data, over, periods of time and whatnot. So yeah, none of this data is super mission critical. It's all really facility data. But being able to run LabVIEW as a service is what made this possible. So, if the server needs an update, the server will maybe go down for a few minutes and then the service just automatically relaunches. Very nice way to kind of take care of that. Another tool, so made a file integrity monitor. So the goal is to be able to track files on disk that we care about and see what has happened with those files. So this is kind of two components to this tool. I created basically a headless server and a GUI for it. So the backend component of it is actually meant to be run as a service using something like this. So you would configure it on your computer, and it will just, so as soon as your computer launches, it'll start monitoring your files that you've told it to monitor. And then the GUI you can go connect to and actually see the status of those files. And so this allows you to select any number of directories that you want to monitor. So, if there's, a couple different folders you're interested in, there, just as like a warning, there's nothing actually stopping you from having this monitor your entire local disk, which will probably wreak havoc if you configure it like that. Yeah, you can, specify certain folders and say, hey, I want to know, what changes happen in these directories. And it actually creates a SQLite database that tracks an overall history of everything that's being monitored, but it also creates a table per each individual file that it's monitoring, where you get the history of that file specifically. So, in this table, you can see the file was renamed, the file was changed, you get the date and time at which it changed, and it also tracks the file hash for you. So you can also compare hashes over time. So you've got, a history table. It's just the general history that's more like, hey, at this time, this file was created. At this time, this file was deleted. At this time, this file was changed. And then you can also dive down into this file specific tables, and you get just details relative to that specific file. Whenever you want to, if you just click flush database, it will drop all of these tables and recreate the, the critical ones so that you start kind of clean when you want to. You can export these results to Excel. And then I also added down here, you can enter custom SQL queries. So, something that's not mapped through the GUI currently, if I just want to, hey, truncate some table or something, I can just go down here and I can type, hey, to truncate this table. So it's two pieces. You've got kind of a back end that's the constant monitor. And like I said, it's kind of meant to be run as a service. And then the GUI is kind of just for viewing those results, and kind of you can also go to the directories here and you can manage what directories that the service is actually monitoring. And it's all built in LabVIEW, so if you want to go take it and modify it to match your specific use cases, feel free to do that. And you're also welcome to just use it exactly as it is. The project, if you download it, has build specs already for creating the front end and back end. So yeah, feel free to use that however you guys want. Another tool, so this leverages the Microsoft Secret Store tools. So this is a way where you can create vaults and you can store secrets in those vaults. So this is all Microsoft technology. This is really just a way for LabVIEW to integrate with the Secret Store. And you can store essentially whatever you want in here, right? It's just going to allow you to store strings in it. Those strings could be anything from, credentials to API tokens to passwords to, really whatever you want, right? You could store keys in there. It does support a couple of different data types. Like I could do like a byte stream or something like that. This API currently only supports strings just because it's the most generalized, right? If you have like a byte array, you can easily convert that to a string when you write it, and you can also convert it back to a byte array easily when you read it. So right now it's just working with strings because it's the most generic, but it does support a couple of different, I think it supports 4 data types. Strings is all it's currently working with. One of the cool things about the Microsoft Secret Store is you can create as many vaults as you want, and those vaults can have independent permissions. So I can create vaults that are either user specific, I can create vaults that are system specific, and I can even remotely access vaults on other systems. So kind of cool. It's very flexible. It's kind of up to you on how you want to administer that. But this API allows you to create vaults, return a list of all of the vaults that are available. It's able to create secrets in those vaults, read the secrets back, delete secrets, delete vaults, etc. I also included in here a PowerShell script that you can just run, and it will do all of the installation of the Microsoft Secret Store tools for you. So it'll install all the dependencies, and it also at the very end of the PowerShell script will prompt you to set a password for your Secret Store. So here, when you run this Secret Store initialize function, it wants a password. Here it's just password. But so when you first run the installation, it's going to prompt you and say, hey, what do you want your initial password to be? I do have a LabVIEW function available that lets you change that password through LabVIEW in the future if you ever need to. But yeah, the password is all you really need to connect to it. And then from there, you can store secrets securely and whatnot. Either make them specific to users, right? If you were issuing like a unique API token per user, you could store that in a user-specific vault in the Microsoft Secret Store. And then your LabVIEW application could just easily pull those out and leverage them for some sort of like web API or something like that. Likewise, if you had like a system API token that every user is using, you could create a local system accessible vault, and then every user can just pull that same token. So you have a lot of flexibility with it. Here's kind of just a simple example where, I'm just creating a vault, returning a list of all the vaults, creating a secret in there that's named super secret password, and the actual value of that super secret password is password. Here I can read that secret by name. So I can say, hey, I want to read super secret password in vault, demo vault, and it returns this value of password. And then I can go delete them. So the goal is just to make secret management a little easier. I kind of heard a good explanation of just secrets, right? I think I read this on probably like LinkedIn or something, but talking about secrets, there was talking about how, well, like, the worst thing you can do in your code is have, secrets like credentials, tokens, etc., hard coded into your application. So the first thing you can do is kind of separate the lock and the key, right? So, the first thing you go to do is move all of those secrets to like a file or something. So now you've separated the lock and the key. So your source code, shows you how to actually, leverage those tools, but the actual information you need to use them is stored somewhere else. The issue you then run into is now you have like a plain text file or something that stores all this stuff. So anyone who can read the file now has access to the credentials. So then you look at encrypting that file. So now you have either some sort of key that you use to encrypt and decrypt the file that you have to store somewhere, or you have like a password from which you're deriving a key that you have to manage somehow. So then you look at like a secret store, and then for your secret store, you've got an API token that lets you interact with the secret store. And it's just a never-ending cycle of eventually, there you have to have something stored somewhere that's easily usable. Just kind of the more layers to that you have, the harder it is for someone malicious to do anything with that. And yeah, secret stores are a great way to kind of mitigate risk, storing credentials and whatnot. For this, all you would need to do is store some sort of password file somewhere. But yeah.
So a couple questions here for you. And
Uh-huh.
I guess for storing that password, you can't just turn on the password display where you just turns into asterisk. That's not good enough.
Yeah, probably not good enough because you can just right click on it and turn it off later.
So question about bootstrapping secrets. How do you bootstrap secrets? I don't even know what that question means, but does that make sense to you?
What do you mean by bootstrap, I guess?
Do you have to prompt the user for the password, or do you hard code it? Maybe
it's exactly what you were talking about, where you have to have some password in there or prompt the user for something. And so you talked about it. You can build layers of obfuscation or layers of security, but at some point you either have to prompt the user to type something every time or hard code something.
Yeah.
That was, but yeah, you already kind of covered that.
Yeah.
And note on the computer screen is probably fine. Just write it on the
yeah, the sticky note under the keyboard. Yeah.
Then another question about do you have plans to integrate with Vault or OpenBow, AWS KMS?
I haven't yet. So I do have integration with Keeper, which is a FedRAMP authorized cloud service as long as you use the GovCloud version. So Microsoft Secret Store would be more of like a internal to your facility type secret store, or either even specific to like a test stand, right? If you had a specific test stand, you could leverage this secret store there. Keeper would be a web-enabled way to do that. So you can store secrets on the cloud. I haven't really looked into other tools necessarily, and I'm not sure which cloud services are all FedRAMP authorized either. I know Keeper's been the one that has been our company's preference. But yeah, I haven't really looked into other ones necessarily.
Well, and you're making this for yourself. So you're going to make the things you're interested in.
Yeah.
You've open sourced it, so if anybody else is interested, they can learn from what you did and integrate that. And that's pretty awesome. So
yeah, absolutely. And then as far, I guess, as not requiring like a user to enter a password or something, I do have another tool that I'll share here in a little bit that kind of does obfuscate that even a little bit more, and allows kind of privileged access and being able to pull passwords and stuff a different way that is more of an IT managed way. So I'll show that here in a minute. But yeah, kind of Keeper integration. So Keeper is another secret store. This is a cloud-based one. Like I said, it is FedRAMP authorized. So, it's good to use from a CMMC standpoint. From the DoD's standpoint, it's secure. You can actually store all sorts of stuff in Keeper beyond what you can store with like the Microsoft Secret Store. So this, you can have your basic passwords and API tokens and credentials. One of the cool things kind of with like database credentials and stuff like that is it actually breaks down like the individual components for you, where you'll have like a key that is like the host name or IP address, and a key that is the username and password, and a key that is the port, and stuff like that. And so it kind of breaks down what's necessary for that type of a secret for you, which is kind of cool. But it can do all sorts of stuff too, like bank accounts. You can store addresses in there, and you can actually store files in there as well. So if you have like a key or some certificates or something, you can store those in there. It does have a very nice web interface as well, where you can manually kind of administer stuff. And it is a cloud service, which is nice. So like we use it a lot for like our IT team will issue us credentials to different things, and they just put them in Keeper. And so from there, I can access them either just by going to the web page or through the API. Yeah, you can either programmatically read these, or you can just go to the web page and you can download files and whatnot from there. So it's been a really awesome tool. This is one tool that this is actually, out of all the tools I'm sharing, this is the only tool that is not yet pushed to Git. It's just about finished, but it's not quite there. So there's a little bit of tweaking before it's ready, but in general, it's working. It's been a cool tool for just being able to store secrets and organize them. And I can either share secrets with my entire company. I can create user specific secrets. I can create folders that certain lists of users have access to. So yeah, you can do a lot of playing around with who has access to what and whatnot. The other one I wanted to share is Bouncy Castle. So if you've never heard of Bouncy Castle, this is a open source FIPS certified cryptographic API tool. So it currently supports .NET, which is really just a .NET wrapper for this. But it can do all sorts of stuff, and there are a lot of different LabVIEW toolkits for stuff like encryption and hashing and whatnot already. This is another one. It does have a few cool features that those other tools don't necessarily offer. So this can do stuff like, it has a whole bunch of key generation algorithms and stuff that don't rely on like OpenSSL, right? It's just one .NET library you need to call. So you can generate different types of keys. It also can do certificate generation, and it can actually convert certificates from like one type to another. So you can generate certificates this way if you want to create some sort of certificate, or if you have one in one format, and you need to get it to like a PPK certificate or something like that. You can do your conversions, and between like X509 and whatnot, you can do different conversions that way. It has basic hashing algorithms, encryption algorithms. It can do signing and verifying. Another big kind of cool thing I think is it includes so NIST recently, they're like in the final round of releasing their post-quantum cryptographic functions. So these are algorithms that are supposed to be quantum computing resistant, so that the idea being that current key public key cryptography algorithms with current technology are extremely hard to break, and it doesn't really make sense to try to like brute force that. But with quantum computing, those could be broken relatively quickly, so aren't necessarily safe anymore. So different algorithms to try to resist the ability of quantum computing to break those. Obviously, it only really becomes a concern once quantum computing becomes more generally accessible to people, and if it got in the hands of like malicious actors and stuff. So for this Bouncy Castle, it actually has so much stuff in it. You can actually implement like full TLS just through the Bouncy Castle library. It can do like TSP, like the timestamp protocol, stuff like that. So I've mapped a small subsection of functions of this, and I'm working on trying to wrap the full suite, but it's probably going to take me, I would say probably a couple months to finish that. It's a pretty big project. So there's stuff in there right now for key generation and for hashing and encryption and stuff like that. And I'm just going to be adding to that as time goes on here and there. So if something you want is not currently mapped, check back on the repository later. Still kind of actively trying to map those features. So kind of going back into passwords. So we created an API for LDAP, which is a protocol that's used to authenticate users through Active Directory. So we found this as a much better way to manage users and to manage permissions than passwords, like in LabVIEW, like prompting a user for some sort of password or something. From a security standpoint, right? People are sharing passwords and whatnot. And then from managing permissions, right? It's a lot more headache. So using Active Directory, we actually found is a much better way because we can create specific user groups. And this is all managed kind of on our IT side, where, we can say, hey, this is a test stand operator, right? So when the LabVIEW application launches, it can say, hey, are you a test stand operator? If not, just close the application, notify them that, hey, you don't have permission to run this, and just close the application. If they are in the list, then they can run it. And then from there, you can have different admin features that, normally maybe they're password protected or whatnot. Using LDAP, we can kind of just automatically elevate user's permissions. In addition to, we can query and store all sorts of values and stuff specific to that user. So we're able to validate that a certain user is a valid user for the given domain that we're in. We can also query details about them. So I've mapped a whole bunch of just common functions that, so the way your Active Directory at your organization is storing information is going to vary some based off of just your IT team and how they set it up. But a lot of these are very, universal things that should work. And it also allows you to execute arbitrary queries too. So if you wanted to just read some arbitrary value, you can pass in what that value actually is to read from. And so one thing you can do with this is pull like passwords and stuff. So you can store passwords in Active Directory. And then I can say, hey, I want to check what this user's password into this specific system. It could even be like a secret store, right? Like, hey, what's their password for the secret store? And I can just query that from Active Directory. And that's kind of all managed by our IT team and whatnot. But yeah, you can do cool stuff like, read phone numbers, etc. I kind of have a little example here of an application. So this just controls a whole bunch of thermal chambers throughout our entire facility. We've got, at any given time, there's usually about 100 users who are using this. So we've got, some Rio hardware that's actually controlling the thermal chambers. We've got a server in between the two, and this would be what runs on our IT network and is able to send commands to the server that therefore sends them to the Rio hardware. The Rio can run the full temperature profiles and whatnot. So we've integrated, LDAP into this. So first example here, there's a couple examples of using this here. So, when we're running a profile, it shows what user is actually running this profile, whatnot. You can click on the user if you don't know who they are, and it gives you a whole bunch of details about them. Like, hey, what department do they work in? What's their email? Phone number if I need to get a hold of them. Because, yeah, they've got a whole bunch of people using this. Not everyone knows who everyone is. Maybe, we need to go find that person. So the ability to query some basic details like that about the individuals. But then also, there's a lot of admin features built into this. So I have an admin menu up here. So when I click these buttons, it just checks, hey, are you an admin user? And if I am, it allows me to view these different GUIs, go create like new temperature profiles, for example, stuff like that. So all of that is just done through Active Directory. No users have to sign in to the software or anything like that. So it's been a really good tool for kind of just authenticating users. I also wanted to highlight.
So that on that LDAP thing, that's really important because if you look at 800-171, there's 110 controls. The first 22, so 1/5 of them, are around access control, and the next 10 are around auditing who has access control. And so you're able to wipe out a huge bunch of the requirements through this, which this was without this is really, really difficult to do. So this is really amazing what you just showed us.
Thanks. Yeah, and it does fully support LDAP-S, which is basically encrypted LDAP as well. So yeah, you can use it for, we use it for authenticating users, validating they have the appropriate permissions, but also we can create custom, how we're reading like a user email or something like that. We could also create any sort of value we want and query that value for a specific user. So we can create custom unique stuff there. yeah, I'm about out of time, so I'm going to try to just trailblaze through these last couple ones super quick. So IP tables, for those who don't know what IP tables is, this is a firewall that's built into all of your Compact Rio devices. By default, it allows everything in and out. This is a free open source way to configure that IP tables in more of a deny all except by exception configuration. So I've gone ahead and mapped all of the NI services. So you can just check the ones that you care about. And here you can set, custom ports and the protocols for those, and just click create script and it'll generate this entire script for you. You can go in, this is just a control, so you can go in and you can manually, change stuff if you want to, or add documentation or whatever. And then basically you can enter the address of your target, username and password, and click upload script, and it will upload the script to it. And this does actually update the IP tables comp file so that all of your configuration is permanent and will persist on, reboots and whatnot. And then I did add a button so you can temporarily disable the firewall entirely or restart the service. If you need to just turn it off for a minute, you can, as long as you have SSH access. If you do delete this port 22 stuff here, that's not going to work either. Yeah, and then the reset script is just going to reload the initial script, which allows everything in and out. So if you wanted to reset it to the original configuration, just click reset script and then upload the script to the target. I have just a simple file transfer GUI to these CRIOs. So this will actually map your file directory on your target, and you can kind of navigate it. You can read the contents of files here. The main driver for this being that kind of application whitelisting, right? It gets harder and harder to be installing third-party software without having to go through IT all the time. So it's much easier to have a custom interface that we've made that I can just include in applications, and it becomes part of like a bigger application, right? So that way, I can kind of control this, and I can, if I'm creating some system that interacts with a Compact Rio, I can just go and build this into it if they need some sort of GUI for, interacting with files. And it does support Git and put, and it does use WebDAV, so it is all secure. Yeah, file transfer GUI. I have this RT-SSH API, so this is just really a wrapper on top of the lib2 SSH functions that NI has released. I've mapped a lot of the common SSH commands that I need to execute to RT targets. So like reading the Linux version, DNS name, device data, run level, echoes, stuff like that, CPU information. You can do OPKG installs and updates programmatically. So a lot of the common functions are already mapped. I also did create the ability to read and write tags from your RT targets this way. So it's just as like a secure way to read current data. So it doesn't necessarily work as like a stream, but if I had IO data on my RT target, I can write those to tags, and I have functions that actually write those to the tags. And then I have SSH commands created that will actually go and read those tags. So something could be helpful. FPGA flash clearer. So this is not anything super complicated. I've just gone ahead and I've pre-compiled empty bit files for every single CRIO, SBRIO, MyRIO, and RoboRIO out there. And this just allows you to get a FPGA bit file that is in flash memory off of the target. So kind of sanitizing it if you needed to send your device out of the facility. And this can be run from the command line. So you can just call this from the command line with arguments that specify the username, password, and IP. It automatically queries the device and finds out what model it is and then loads the appropriate bit file for you. Or you can just use the GUI, right? And you can type in that information. I have the CRIO sanitizer, which is very similar. This just clears, it just wipes the disk. So volatile and non-volatile memory, reboots it after the fact. It's not like a full-blown sanitize per se, but very close. So yeah, get it for getting that out of the facility. I have this event log viewer. So there is in LabVIEW the write to system log functions. I found it somewhat limiting because A, it can only write to the application log, and B, it can only write to the source of National Instrument software. If I've got 20 different National Instrument software applications on my computer, all of those things get logged to that source. So this is an API for reading and writing. So the other thing you can't do with the native LabVIEW functions is read from the event logs. This allows you to read. And it also allows you to create new log sources. And this GUI is way, way faster than the Windows event logs. If you've ever opened that, it takes forever to open. And then configuring your filters and whatnot is kind of complicated. So I have a GUI here that loads all of your available logs. You can navigate the logs, and you can apply either filters by level or by source here, and kind of filter that down. This is trying to just tackle kind of auditing and accountability section of NIST 800-171. I do have a dynamic security tester for LabVIEW, so this is for sniffing packets. This does use npcap, which I found some LabVIEW code out there that people had written for stuff like this, but it all used WinPcap. This uses npcap. So it'll list all of your adapters. You can select the adapter you want to sniff. You can also filter by stuff like protocols and ports and whatnot. And then click sniff. It will give you live graphs of all your data going in and out until you turn the sniffing off. And it also generates 2 reports for you. So one that just is statistics on the amount of protocols percentage-wise, and then this one that actually breaks down each individual packet that it caught, and what the protocol was, where it was going, where it was coming from, whatnot. I have a syslog API. There are a bunch of these already out there on VIPM. The one main difference is this one supports TLS. All the other ones I saw used UDP, which writes to port 514. This one supports UDP, but it also supports TLS to port 6514. Other than that, it's really not anything different than the other syslog APIs out there. It can act as a collector and logger. I have this virus total API, so this allows you to scan files for like malware and security vulnerabilities. This is a web service. You can just go to the web page and upload files. They also have an API. You have to issue yourself an API key. It is free to issue yourself one, but there's a paid tier that gives you better features. You're also rate limited at like 4 queries per minute or something with the free version, but yeah, I just have a simple LabVIEW API, so I can connect with my API token, upload a file, and then I can read back a list of reports. And so this will compare it against a whole bunch of different security vendors and return statistics basically on how many security vendors mark this as malicious, suspicious, undetected, harmless, or just didn't respond at all, right? We had a timeout. So it's a little slow, hence the long polling between. And yeah, I'm also rate limited on the free tier, so I'm checking if it's done every 30 seconds, but it can be a nice tool for reading those files. This is really just a GUI for what Sam just presented. I just created a simple GUI for creating a allowing you to select a project, being able to click run, have it generate the full SBOM, and then just save it. So it was really just a GUI. All the hard work here was done by Sam, so kudos to him again. Static security tester, so this is still quite a bit of a work in progress. The goal is just to highlight potential security vulnerabilities. It's still very manual, but it's basically just scanning a LabVIEW project for potential security vulnerabilities. Like, so if for example, if you're connecting to a database, it detects the database functions. It highlights, hey, those database functions were used. Make sure that they haven't like hard coded like usernames and passwords and stuff into your code, stuff like that. Or it might detect unencrypted network communication protocols. And it just says, hey, make sure if whatever they're sending on these isn't like CUI or anything. And I just also included stuff like checking for unit tests. When you're done, you can click save and it generates a report based off of this checklist. It's still very manual. It just does the identification for you automatically. I'm working on scripting to actually do some of the common investigations automatically, right? Like if you have the database connectivity toolkit open function, check if there's string constants connected to the username and password, stuff like that. I have this integration testing API. It's really just a wrapper around JKI Karaya, which we use Karaya for all our unit testing. This is a way where you can drop these functions down into your top level VI to just kind of test the entire architecture and whatnot. And you can enable and disable this from the start. They are also set up so there's a conditional disable structure in each function so that if it gets left in your code and you build it, it's not going to do anything in your runtime engine in case you forgot to clear it up. I did also include a scripting VI that if you run and pass in like VIs, like a directory for VIs to scan, it will go find all of these functions and delete them and clean up the wires. So, basically a simple way to just, hey, drop these in, test my architecture, really, the whole application together. And it pops up, the Karaya window where you can see your test results and, really just wrappers around those assertions with some additional logic. And then also just a simple lab updater. So this is a service and a client, so you can remotely deploy updates and whatnot, just because surrounding CMMC, right, developers are losing permissions to do a lot of administrator functions on systems. So this way I can deploy a service that does have admin credentials, so I can transfer a update, either an exe or an MSI, to it and have it remote execute, run remotely. That's kind of it. Sorry, I kind of went just a hair over. But here's my contact info if anyone needs to get a hold of me. If you have questions, feel free to reach out. And then here's the link again to those projects. You're welcome to do whatever you want with those.
That's a lot of information in just a short amount of time. So this will be recorded and put on that site, so you can go back and review that kind of more carefully. But a lot of great information, a lot of great tools there. I'm really excited about having that available to our community. So huge kudos to you, Tim, for all the work on that.
Oh, no problem.
Yeah, that's and it's cool that you open sourced it, made it all available to everybody. So very cool. Yeah.
Thanks.
So we're going to go over to Hunter now at JKI. He's going to show us a little bit